Hello all. So this video goes through how to solve the second homework question on the first classical mechanics homework. So part A of this problem asks you to find the angle between two vectors A and B using the dot product. So as a quick review of the dot product, for two vectors x and y, you can write the dot product either like this with a little dot in the middle of them, or you can also write the dot product like this, where the superscript t on the x means transpose, but all a dot product is the sum of xi, yi. And what that means is that for a 3 vector, or a vector with 3 components, the dot product of x and y is simply x1, y1 plus x2, y2 plus x3, y3. And now another property of dot products you'll need to solve this problem is the following equation. So if you have the dot product of vectors x and vector y, that dot product, which is a number, is also equal to the magnitude of vector x times the magnitude of vector y times the cosine of the angle between x and y. So that's all of the background we need to solve this problem. So this problem wants us to find the vector between, the angle between vectors A and B. So we'll do that using the above formula. So we'll have to take the dot product of A and B and set that equal to the magnitude of A times the magnitude of B times the cosine of angle AB. So first let's calculate the dot product. So the dot product of vectors A and vectors B is equal to the dot product of vector 1, 2, 4, dotted with vector 4, 2, 1. So that is equal to 1 times 4, which is 4, plus 2 times 2, which is 4, plus 4 times 1, which is 4. So the dot product there is 4 plus 4 plus 4, which is 12. The next piece of the equation we should solve for is the magnitude of A. So the magnitude of vector A is simply the square root of A1 squared plus A2 squared plus A3 squared, which would mean this is the square root of 1 squared plus 2 squared plus 4 squared, which is the square root of 1 plus 4 plus 16, or the square root of 21. Finally, we need to find the magnitude of vector B. So that will also just be the square root of the sums of the squares of the components. So 4 squared plus 2 squared plus 1 squared, that the first component, the second component, and the third component. So that is also the square root of 21. So now plugging all of these values back into this equation here, we get that 21, which is the dot product, is equal to the magnitude of vector A times the magnitude of vector B times the cosine of the angle AB. So 21 is equal to the square root of 12 times the square root of 12 is just 12, times the cosine of the angle. So 21 divided by 12 is equal to the cosine of the angle. And by doing the inverse cosine, you get that the angle between vectors A and B is about 55.2 degrees. Let me write that just a little bit clearer. 55.2 degrees. So that's part A. Nothing too bad there. Going on to part B. Part B is asking you to do basically the exact same math, just in sort of an application. So what it tells you is you have two vectors. Vector A is kind of hard to see in my picture, but vector A is the vector that goes from this front bottom corner of my cube to this back top corner of my cube. That's called the body diagonal. It goes diagonally throughout the body of the cube. The second vector it gives us is a face diagonal, which goes from this front bottom corner to this top front corner. So it goes diagonally across one of the faces of the cube. And so this question wants us to find the angle between those two vectors. So it gives us that the vector A, which is the body diagonal, is 1, 1, 1, and the vector B, which is the face diagonal, is 1, 1, 0. So I can write this as follows, using the same formula as last time. I can say that A dotted with B, or you may see this as A transpose B, is equal to the magnitude of A, magnitude of B, cosine theta AB. All right, and now the same process as last time. A dotted with B is 1, 1, 1, dotted with 1, 1, 0. So that's 1 times 1 plus 1 times 1 plus 1 times 0. So the dot product there is 2. The magnitude of A is the square root of 1 squared plus 1 squared plus 1 squared, or the square root of 3. And finally, the magnitude of B is the square root of 1 squared plus 1 squared plus 0 squared, or the square root of 2. All right, so combining this all together, we have, so using this equation and the results we just solved for, we have that 2 is equal to the square root of 3 times the square root of 2 times the cosine of the angle between vectors A and B. And so doing a little algebra here and taking the inverse cosine, you get that the angle between vectors A and vectors B, so the angle between a body diagonal and a face diagonal of a unit cube, is simply 35.3 degrees. So using the dot product, or you may also see it called the scalar product, to find the angle between two vectors is a pretty common problem in this class. So make sure you're comfortable with this type of problem. And if you have any questions, please feel free to contact Morten, Jeremy, or myself, and we'll do our best to clear it up.